Welcome back. So we're talking today about tools of navigation. And a couple that you have to talk about in your classroom are going to be compasses, astrolabes, and sextants. And I couldn't get you an astrolabe because they're incredibly expensive. And sextants are also pretty expensive for ones that actually work. So we're going to work with a couple different models of one. I did get you some compasses to work with, to start with. Now, here's our compass. Okay, so we know that a compass works because the needle has been magnetized, and so it's going to show us the magnetic field around the Earth. So that magnetic field is really important. We want to connect back to the fact that the Earth itself, the core of the Earth, is a magnet. It's a liquid metal ball that's rotating, roughly the size of Mars, and it creates a magnetic field around the Earth, which is why we're all alive. Because this field is not only showing us where a compass works, more importantly, it is protecting our entire planet from the energies from the sun. Without that, we would all have died a long time ago from radiation from the sun destroying us. So, go magnetism. Anyway, with the compass, we have a couple different parts. So, compass has a red arrow, this red arrow on the base plate. So you have a base plate and then you've got a knob that's going to turn. The compass base plate has got an arrow. That's called your direction of go, called the dog. So there's your dog. That's the way you want to go. You also have a red needle. The red needle is always going to point towards north. You cannot use a compass if you hold it like this. You have to hold it on the flat of your hand. If you hold it up like this, it won't work. It's got a balance. It's going to hold on the flat of your hand. You also have a dial, and that dial is going to point to whatever number you want to go to, whatever part of the compass. So it's 360 degrees, making a complete circle, starting at 0 degrees, which is north. So let's say I want to go north. I would need to, if I want to go north, I need to align north with this nice red arrow. So I want to align north with that arrow. There it is. Now, if I look down at my compass flat, I can say, oh, my red arrow is going this way. My dog, my direction of go arrow is going this way. So I have to turn, if I turn the compass, now my direction of go, where I want to go is that way. My needle is lined up with north. So we're all lined up. So that direction in front of me, right through the camera, is north. That's fantastic. That's easy. Well, what if I want to go west? Well, I need to turn the dial to find the west, little w. It's about 270 degrees. All right, that looks good, except now the red arrow on my dial is not lining up with the red arrow of the compass. So now I have to turn my body going the wrong direction. I'm trying to line up the black arrow to it. That's not going to work. I need the red arrow. So I'm going to run this way. All right. Now my red arrow is on the red arrowed part of the compass. Now the way you can think about this, if this is the DOG, direction of go, and then the red arrow, let's call that Fred, and then you've got a little red house or showing where so there's the dog house. So if I get Fred in the dog house, in the shed for instance, then my direction of go, my dog is all in the lineup, okay? And so I follow the direction of go. So I want to line Fred up, Fred the arrow, red arrow, with his shed. If I do that, then my direction of go is in the right spot. And so I'm going to go that direction, okay? So that works pretty well. Now, they can find cardinal directions, and that's what a compass does. It cannot tell you where you are, it can only tell you what direction you're pointing. So it takes a few minutes. They can kind of figure out which way they're going. You can have the kids all put them in here, working in pairs probably, or in small groups, and then you can say, okay, now face west, and you'll see if they can track west or north or south or whatever. That's pretty limited though. What you want to go further is you want them to then, you can create, for instance, as a practice piece, a simple 3, maybe 4-step scavenger hunt, essentially. So you start at your table, wherever your table is, or you start at a predisposed, maybe there's an X on the ground, and you move from there to the finish point. They have to find out where the finish point is. And you say, okay, this is going to be 300 degrees, and I want to take 5 steps. Okay, so I figure out where 300 degrees is, I line up Fred on the red arrow, so 300 degrees. I line up Fred into his little house on my thing. My direction to go is that way. So that's going to be 300 degrees. Okay, so then I take 5 steps. Normally we say paces. A pace is 1 step and then a second step. So left, right, and then back to left. Your kids are going to mess that up every time. It's a nightmare. Don't do it. Just go with steps. 1, 2, 3, 4, 5. And remember, their steps are a lot smaller than yours, so if you're pacing this out and they're not going up in the same place you are because you're taking your giant adult steps, make sure to kind of cut back a little bit so that their steps match what yours are. Okay, so give them like 2 or 3 steps to find. So they go from here to that desk over there. So you find it. So you say, I want to go from here to that desk. You don't tell them this. This is how you're building it. So from that desk, and then you find out, okay, I'm going to move the arrow till it's lined up. Oh, that's 280 degrees. So and that's going to be 1, 2, 3, 4 steps to that desk. Great. So once I'm at that desk, where else am I going to go? Oh, I'm going to go to that window across the room. So you line your compass back up to that window. You say, oh, that's 120 degrees from that desk. And then you go however many steps. Okay. That would be practice. The better part is once they can do that in their groups, take them outside and have them come up with their own scavenger hunt. Okay. Now, and you can couch this in terms of trying to find buried treasure. However, that's not historically accurate because as far as we know, there's only 1 or 2 cases of people who actually did that. And the one case that they do know about, he really just dug it into like a part of his backyard, and he dug it himself up. That later on, it wasn't that much of an exciting treasure map. It was, no one did that, but that's okay. Keep the story alive, I guess. So they can just find a scavenger hunt, essentially, 3 or 4 steps, and then they have to write out their clues of what direction, where do you start, what direction do you go, how many steps do you take, okay? And then each place you stop should be something. There should be something there, whether it's a rock or a manhole cover or a crack in the sidewalk or a bush or something. Don't have them just stop right in the middle of nowhere. That's really awkward. It's hard to get to. And then a finishing point. And then they take that map, the directions, and they pass it to another group to see if the other group can follow their directions. So they have to write the directions for another group. The other group's going to split with them, and then they have to follow group. So their group A, they come up with their own map, they give it to group B. Group B is going to then walk through it and see if they get to the end. Group A is going to take group B's instructions, and they're going to walk through theirs to see if they get it right. Okay, and everyone compares. If you write it wrong, the groups who didn't get it, maybe they can go a second time. This is really handy at recess, for instance, or any other time that you're outside that's less structured. You can pull the groups that were not able to get it correct the first time. To do it, you can also just say, hey, do you guys want to make more treasure maps or whatever? Because some kids might be very interested in that. It costs you nothing, just as long as they bring the compasses back, it's all good. Okay, so you can always encourage them to use this outside of structured class time. So that's a compass. It doesn't show you where you are, it only shows you what direction you're traveling. Now, this is an astrolabe. An astrolabe is a very ancient item, comes from Persia, so the Middle East, and it is a stunningly complex, intricate, well-designed instrument for the time. Some people consider it the first computer because you have inputs and outputs. It was finely made. They were extremely expensive. The person who had to use it was very literate. They had to be a scribe of some kind to be able to understand the charts. And all these lines represent where the stars are going to be on given months and weeks of the year at different times. So being able to use it lines up with giving you what's called the latitude of where you are. Now that works most importantly if you're out in the middle of the desert or you're out in an ocean. You may not have landmarks nearby, and the latitude tells you how far north or south you are on the globe. Okay? Now, this is the simplified version. This is a protractor. It's got a straw taped to the top. I've got a string tied to it with a little hex nut. It can be a washer, anything that's heavy. Okay? Basically, as I change the angle of this to look up into the sky, something on the ceiling, for instance, I'm going to be changing where this line goes, and this is going to be telling me what is my angle? My angle is going to tell me my latitude. So for instance, if I'm standing right here and I'm looking up at the ceiling at one object, a person in a chair to the side or closer or further away from where I am is going to have a different angle because they might have to look up a little higher or not so steep depending on where they are in the classroom. That's latitude. So if you say, okay, look behind me, and this is the spot you want the wall to, and then you put a spot right here on the wall, or a little higher up, so that's the spot you want to look at. The people in the front of the class are going to have a different management than the people in the back of the class. And that would be a way to describe latitude. So these people up in the front, they're further north, okay? The people in the back are further south to be able to view this object that you have up here. And it's all based on the angle that they're measuring off of this. So I can't get you an astrolabe, I can't get you a sextant, but we can use this. And the sextant is basically an astrolabe that was developed later and uses both mirrors and lenses to be able to look at the sun and show where is the sun hitting above the horizon, and that will also tell you latitude. And the sextant's a much more detailed, finely tuned instruments. It's more accurate than the astrolabe was. They're both fantastic tools, though. So anyways, they both work the same way. They show me the angle to the sun or to the stars. So this is how you would use it. So here's my horizon, whether that's an ocean or a bunch of sand, and I sight along a piece of the metal, or in this case, the sextant. I would sight along a lens assembly, and then the height angle from the horizon to that star or to the sun, that tells me my latitude. Once I know where I am. Now, to do that, you also had to have a calendar. If you did not know a calendar, those tools became ineffective. So it required a great deal of learning to get it right. It wasn't just something easy to do. So compasses showed you direction, and based on the gravitational pull, the magnetic pull of the Earth's core. And then you had a sextant and a astrolabe and sextant. Astrolabe is very old, very complicated, amazing piece of equipment. Sextants much later. Both of them do the same thing. Show the angle of the sun or a star above the horizon to tell you your latitude, how far north or how far south you are from the equator. Okay, thank you. Gosh, barely made it. Thank you so much.